Welcome back, everybody. We are up to lessons 17 and 18. And what lessons 17 and 18 are about is an important characteristic of a rational function, and that is something called an asymptote. An asymptote, as it says here, is a line that gets infinitely close to a function's graph but does not actually meet the graph. When you zoom out, it might actually look like it touches the graph, but it never actually does. So that is what an asymptote is. There are two different types of asymptotes that we are going to look at in today's lesson, and that is a vertical asymptote. So those are asymptotes that go up and down. And we're going to look at horizontal asymptotes. So those are asymptotes that go left and right. So to find vertical asymptotes, all we do is we set the denominator equal to 0 and we solve for x. The vertical asymptotes will be the vertical lines at those points. And to find horizontal asymptotes, we're going to separate out the fractions and simplify. The constant tells you where the horizontal asymptote is. So with that in mind, let's go ahead and look at the examples for this lesson. So for number 1, find the vertical asymptotes of the following function. As it says in the lesson notes, we are going to set the denominator equal to 0 and solve for x. So the denominator in this case is x plus 4. We're going to set that equal to 0, and then we're going to solve for x. So if I do that, if I subtract 4 from both sides, I end up with x equals negative 4. X equals negative 4 is the horizontal asymptote. And to give you an idea of what that looks like, okay, I'm going to go on Desmos and I'm actually going to graph the function and I'm going to graph the vertical asymptotes. So we have 6 over x plus 4. That's the function. And I'm going to graph the vertical line x equals negative 4. So the purple graph here is the function, and the vertical line is the asymptote. And you can see as I zoom out, the purple graph gets infinitely close to the black vertical line, but it never actually crosses the black vertical line. It does that up here. It also does that down here. That is what an asymptote is. It gets infinitely close to the graph, but never actually crosses it. So that's what an asymptote looks like visually. For number 2, again, we're going to take the denominator and we're going to set that equal to 0. So 2x minus 2 equals 0. So I'm going to solve for x. I'm going to start off by adding 2 to both sides. So 2x equals 0 plus 2. So I end up with 2x equals 2. And then I can finish that off by dividing both sides by 2. And I end up with x equals 1. So the vertical asymptote for number 2 is x equals 1. And if I take a look at the graph, so 3 over 2x minus 2, so 3 over 2x minus 2, there's your graph. And if I graph the vertical line x equals 1, you can see the same thing happens. In this case, the vertical asymptote is blue, and it gets infinitely close to the red graph both up top and at the bottom here in the negative direction. They get infinitely close, but they never actually intersect. That, again, is what an asymptote is. So that's numbers 1 and 2. Those are vertical asymptotes. Horizontal asymptotes, okay, again, what we're going to do is we're going to separate out the fractions and simplify. The constant tells you where the horizontal asymptote is. So what do I mean by that? Let's take a look at number 3. So number 3, I have 120 minus 4x over x. Now, what I mean by separate out the fraction is I'm literally going to separate it out. Okay? So that's going to look like something like this. It's going to be 120 over x minus 4x over x. I literally separated out the fraction in the middle. 120 over x minus 4x over x. And when I simplify, that becomes 120 over x. There's nothing I can do over here. Minus, in the second part, I have x up top and I have x down below. So those cancel each other out. So this becomes 120 over x minus 4. So my horizontal asymptote is going to be at y equals negative 4. Whatever the constant term is, the constant in this case is negative 4, that's your horizontal asymptote. So the horizontal asymptote for number 3 is y equals negative 4. And to show you what that looks like, visually, let's again go back to Desmos. And let's look at the graph here. So the graph was 120 minus 4x over x. So 120 minus 4x over x. So there's your graph. And I may need to zoom out so we get a better look here. So there's our graph. And my horizontal asymptote was y equals negative 4. So I'm also going to graph y equals negative 4. So you can see that gives me a horizontal line at negative 4. And you can see the horizontal asymptote does the same thing. As I zoom out and move really far to the left or really far to the right, that asymptote gets infinitely close to the green graph, but never actually intersects the green graph. So same concept as a vertical asymptote, except horizontally. So let's do number 4 now, quickly. So we have 500 minus 8x over 4x. I'm once again going to separate out the fraction. So this will be 500 over 4x minus 8x over 4x. So 500 over 4x minus 8x over 4x. And now I'm going to simplify. So in this first term here, in this first part right here, 500 over 4x, the only thing I could really do is do 500 divided by 4. I can do 500 divided by 4, so I'm going to use my calculator for that. And 500 divided by 4 is 125. So this becomes 125 over x. Minus, in the second one here, and that one, there's a couple of things I can do. I can cancel out the x's, like I did in number 3. So x up top and x down below cancels out. And then I could do 8 divided by 4, which is 2. So that simplifies to 125 over x minus 2. The constant is negative 2, so my horizontal asymptote is at y equals negative 2. So y equals negative 2 is the horizontal asymptote. And that is it for this lesson.